So with the power of gRPC and Protobuf, we are able to get a improvement of 90 milliseconds and 9 milliseconds. Then again 80 milliseconds and 8 milliseconds. Almost 10x का improvement we noticed. So that's a huge. Welcome back to the channel. What are you doing today? So today we are going to build a API server which is 10 times faster than the traditional REST-based API server. So today we are basically going to implement API server using gRPC, and we will also implement a API server using REST API also. I mean the HTTP standard HTTP protocols, the REST-based approach, and then we will do a performance comparison both the API servers, okay, and then see who wins finally. When you build microservices using gRPC, it becomes 10 times faster than a traditional REST, and that is we are going to prove today also and test today also. We just show you the metrics on a surface level. So this is the P95 latency for REST-based API server. P95 means 95% of the request took around 90 seconds to respond. We fired around 46,000 requests in 7 minutes. So that was about the REST. And for gRPC, you see the P95 latency is only 9 seconds, or only it's 10 seconds. And the second iteration, I did a second run also. In REST, it was 84 milliseconds. In gRPC, it was 8.7 milliseconds. We fired around 50,000 requests here in the same 7 minutes. So there are a lot of things that we are going to explore and how to build this. So before going to the code base directly, what I will do, I'll give you a brief overview of the architecture first, like how I have designed the microservices. So if you go to any folder, you'll see there are two microservices, Go microservice and node-based microservices. So let me just explain you in brief what does each of these component do. We have created another script in order to load test the services. We have created a script using K6. It establishes HTTPS connection or HTTP connection with the node service. All right. And node service is basically takes as a proxy service, okay, which proxies the request to Go service and fetches the response and sends back to the client. So that's how the entire skeleton of both the microservice that we've implemented, gRPC microservice and REST-based microservice. So the change comes is in this place when we are communicating between two microservices, that is a node to a Go microservice. This is where the things change. So what we can do, we can implement a first we'll implement a REST-based microservice. I mean, we'll establish a communication between node and Go using a REST protocol. So in the next thing, what we are going to do, we are going to implement the same thing, but here using gRPC. So the communication protocol between my Node.js proxy and my Go service will be gRPC here. And one more thing that we have done here, each of the Go service holds around 5,000 products. Okay, I mean products, as you can think of products as this kind of schema. Okay, so I have simulated in the code to generate 5,000 product sample product description, so that, and it will act as a simulation database for us. Okay, we do not have a real database connectivity right now, but this is sufficient to do the performance comparison. So I've created 5,000 random products like this. I just go to one of the services. Let's go to the REST-based microservices first. So here what I have done, I have exposed two endpoint. One is for product, yeah. So then we have two endpoints here. Product, which is a get request, okay, to get a particular product by the ID, and then we have another get request to search products with a query parameter, okay, and a limit parameter, like how many records I want to limit in the particular read. So here the limit can go to 5,000. I mean, in a single request I'll try to fetch 5,000, and then we'll see who performs who performs better. Okay, so this is our complete cycle of a request using both the flows. So this is about the high level architecture, okay, like how the things are working here. I mean, how the architecture is being designed. It's simple architecture. It's just a service to service communication that we are doing, nothing more, right? So you can see, and the same, yeah, same, we have two endpoints here also, so that the request can be proxied to the Go service. So as I told, node service just acts as a proxy to bypass the request to the Go service. All right, now I'll just walk you through the code once. Okay, first we'll go to the REST-based microservices. Before I jump to the code, in the meantime, let me just do one thing. Let me just start the load test scripting. So in the load test, before going to the code, I'll just show you the load test script once. So in the load test, before going to the code, I'll just show you the load test script once. Okay. So in both the microservices folder, we have a K6 file, right, which does a load testing for us, right? So we have a 7-minute test window where in the first 30 seconds we'll test with 50 users. Then for the next 4 minutes, we'll gradually increase the number of parallel users or virtual users to 200. Then for the next 2 minutes, we are going to gradually reduce the number of users to 100. Then finally, in the final 30 seconds, we'll drop to 0. So this is your testing, and we are testing two endpoints. One is to get the product by its ID, and one is to get, search products by the search term and the limit. And limit can have a value of 0 to 5000. In a particular request, I can request 2000 records also. In a particular request, I can request three records also. It's completely random that we kept like that. Okay. And these are the search queries, sample search queries that we are going to do. So in both the REST and this microservice, the files are same, only the base URL changes because we have two different proxies, right? So this is the Node.js proxy for gRPC service, and this is the Node.js proxy for my REST microservices. So I've already run this load test script twice, but again I'll just run it once for you. So this is where we are running both the proxy server. So this is our first proxy. This is my REST-based microservice ka proxy hai, and then we have a gRPC-based microservice ka proxy is running on 3000 port. Now what I will do, will parallelly, let's just start both the scripts. All right, just to do another round of load testing for us. So let's run it parallelly, and you can see the test is going on. The request is being hit to the Go server because this is the final destination server for each request. And similarly, we have another Go server, which is the gRPC based Go server. So this is the HTTP based Go server, and this is the gRPC based Go server. Both are serving to the user request here. So let it run in the background. So in the meantime, now let me just walk you through the code once in brief. Overall, I'll just give you an idea. So first, let's go to the node-based, REST-based microservice. So first, we have that entry point, which is acts as a proxy. It's simple, just built using the Express server. It's just a Express server. Then we have defined the host port. Where my Go server is running. So in this case, so this is my gRPC based, and this is my REST based. So the node service is running on, for REST part, the node server is running on port 8081. Alright, so this is running on port 8081, and this is running on port what? 8080. Alright, and this code is simple. Anyways, I'm going to push this code to my GitHub account, so you can access this code base from there also. Okay, so this Express server is pretty simple. It's just have a proxy to forward a request to Go service. You see, we have a proxy endpoint written here, and it just routes the request or forwards the request to the Go server. That's all. Now, if you just go to the Go service, so what we have done, we have a main.go file here. So to keep it simple, I've kept it in one file only. So this is, I'm using Gin to create a local HTTP server for me. So it's similar to Express, just like you create a HTTP server using Express in Node.js. So Gin is for Go. So using Gin, I've created a simple HTTP server. Okay, and we have two routes here, as I showed you, right? Here we have two routes. So these two routes are defined, and then we have the corresponding functions to get the product by ID. So what it will do, it is going to scan through the products list. 5000 product list I told you, right? So those 5000 products I am already generating using, I have a random generator function which does nothing but it generates 5000 products and puts it in a variable or a global variable like here. This get product by ID will find that product from the list, and then we have a search product function which does nothing but based on the query string and the limit parameter, it will start searching. It will get the resembling products and just give it the response. So this is about the REST-based microservice. There is nothing much or new here to learn. So now what we will do, we'll go to the real thing. So this is where the gRPC-based microservices come into picture. So the cool thing is the communication that happens between this node service and Go service is happening via gRPC protocol, and the data serialization that we are doing here, for data serialization we are using simple JSON, right? But in gRPC, what we are doing, we are using protocol buffer, okay, or shortly known as Protobuf. So I have already explained about Protobufs and its benefit in one of my video, where I discussed how LinkedIn was able to reduce its latency of a page using Protobufs. So I'll attach that link in the description. You can go ahead and watch that out. Okay, you'll understand Protobuf in detail, but don't worry, we are here in this video also I'm going to discuss in brief about Protobuf. So this Protobuf is a protocol data serialization and deserialization technique designed by Google. So this is what we are going to use. It is similar to JSON, but the best thing is Protobuf is serialized into binary format. So here Protobuf is being used, right, to communicate between Node and Go services. Now if you see here in the Node services folder, we have everything as traditional. We have Express server, simple, everything is there. The new thing we have is the product.proto, a proto file, which defines the schema of that message, I mean schema of the packet that I am trying to exchange with the server. For example, and as I showed you, we have products, right, list of products. So I have defined the schema here, alright. So in both the services, you will see that we have a product.proto file. Here also we have imported product.proto, and this is from my package only. I mean from my GitHub account. I pushed this product.proto file. So I'll come to that also. Finally, we are using this schema, and if you see here in the proto file, we have defined what is the type of the request, what is the type of the response it should send, and this is both these packets are valid for my first API endpoint. Alright, if you see here, we have this get product by ID, right? So this is what it is going to be used, get product by ID. So this product request and product response are meant for that. Next, for the another request for the search query, I have this kind of schema defined for it, alright, using which they will be communicating with each other. So in order to implement Protobuf in gRPC, you have to first define the proto class files, which will define the schema or the signature of your request. It basically acts as the contract or the request schema and response schema between two microservices. That's what we are defining here. Now once this is defined, so what I have done, similar thing is there in the Go based microservice also. Before jumping to the Go based microservice in gRPC, I'll just show you what we are doing here. Using that proto file, we are using gRPC proto loader file so that I can load this schema so that my node code understands, right? Node.js code understands about the schema. So what I have done, using that product.proto file, this proto file I've just loaded it, alright, and I fetched that definition and all. Then what we are doing, we are creating a client, a gRPC client which communicates with the Go based microservices. So this microservice that you see, if I go here, this microservice that you see, it runs on port 500, sorry, it runs on 50051 port, and this one runs on 3000. Alright. Now what we have done, we have created a client. So right now we are discussing about this component. Okay. So here we have created a client which can communicate to the Go service running on 50051, a gRPC client we have created. So this is the gRPC client that we have created. Now once we have created that, so this is a simple Express server. Express server is for what? In order to make K6 talk to my proxy server. That's why we have this Express server. Now once I get the request, what I am doing, if you see, I'm calling two functions here, right? I mean, on the gRPC client, it's kind of a remote procedural call. That's why it is known as gRPC. It's just like you are calling a function defined remotely. Get product and search products. Now, how is it defined? I'm going to show it in the Go service. So this client, what does it do? This client basically communicates or talks with the Go services. And these functions are the procedures or functions defined in the Go services. So these two functions that you see that are being called here, they are actually defined here, get product and search products. I'm going to show you, don't worry. Yeah, what happened? Yeah. So these two functions are or procedures are defined in the Go services, and that's how we are able to call that. It's just like, it's just, if you can say, it's just like calling a different function present in another module. That's why it's known as remote procedural call, which is derived from procedural call. Procedural call mein kya hota hai? You just, procedural call means you're calling at some function, right? So RPC is for remotely calling calling a remote function. So gRPC is built on top of RPC. So this is the core or the essence behind the gRPC. Now we are done with the discussing about this proxy, gRPC proxy built in Node. Now let's just go to the Go based microservices. Now if you go here, what I have done, I have imported the product definition or the .proto definitions from my own package. I pushed this into my GitHub. You can go to my account and you find this my packages folder. Okay, if I just show you here, you'll see that the product proto definitions I have already pushed here, okay, today only. Yeah, the same definition, the same schema has been given here, but along with that you will see that there are two more things: product pb.go, product gRPC pb.go. Now why do we need it? Because in case of Node.js we did not need, right? Only the product.proto was sufficient. Now why do we need this kind of thing is, and how did they come first? Let's just discuss about that. So how did this two file come? For that, what we have to do, we have to run a proto compiler command, proto c command, so that this definition, I mean, if you see, I'll just show you the file first, okay? Yeah, using this proto c command, what we will do, will convert. It's just like compiler, just like you, in order to convert a cpp program to its output.out file, we use a gcc compiler, right? Similarly, we have proto c compiler, using which we can create compiled version of this, so that they can be understood by the compiled language, because Go is a compiled language. Node.js is not a compiled language, it's a JIT, just in time compiler wala language. But in order to use proto classes in Go, you have to compile it using protoc command. You see, you have to install the protoc compiler first. You'll get the installation instruction and everything here. All right. So you can go through this site and you can set up protoc in your local. I've already installed that. So if I just show you, let me see if I can print the protoc version. Yeah, if you see, I've installed the version 29.3. So this protoc compiler is already there, and in order to convert the file, the proto file, this product.proto file to this compiled version, we use this command, okay? Because we want to compile it to a Go compatible version, so we are using this go out function, okay? Go out and go gRPC out. So using this command, you can compile the product.proto file to this compiled classes. If you just go, you will find that Go relevant syntax are present in this compiled file. Finally, this is what we are going to use in this microservices. Now if I just go through this code, I mean walk you through this code, you'll see that first we'll go to the main function. We have a first I have generated 5000 random products, just like we did there, okay? I have again the same random generator function above, defined above. So this is what is generating the random 5000 products for me. Then I have created a gRPC server using pb. What is pb? Pb is nothing but the proto compiled classes that we imported from this package. So this from this package, this compiled classes that you see, right, that has been imported. All those have been imported as using the pb class, okay, Protobuf. So using this gRPC package, if you see the gRPC package, I have taken it from google.golang.grpc, the official gRPC package for Go. Using that gRPC, first I am launching a local gRPC server. Then I am attaching it with the mock data that I have built. Obviously, you can communicate with the external database, but right now I have not made that database connectivity. That's why I mapped it to the mock database server. Now using this code, I'm able to run my gRPC server. All right. Now those two remote procedures call that I was about to explain you, which I showed you here, right? Here we are basically calling two products. Okay. If you see, there are no endpoint exposed. So if I just go here, just to here what we have basically get product by ID, then we have search product. So there is no endpoints exposed actually. Okay, there are only two procedures defined, which the client can call remotely via gRPC. So if you see here, we call this get product, right, procedure from the Node.js client, and this get product is defined here. You see here, there will be a get product procedure. Yes, see, this get product procedure is defined here. It then gets all the request data, response data, because if you see, we are sending a product request. That means, yeah, this product request that you see, right, this product request is being sent here. You see in that format. This is an instance of this product request message packet, and this is where we are capturing the data. If I just talk about the second function, search products, if you see, we are passing query and limit here. इसमें क्या था, search request में query and limit था, right, 2 parameters. So that's what I have passed here, search products. Now in the main.go file, if you go to the search products file, we are getting the request body में क्या है, search request, it is same as the search request, right? As defined in the proto class file, search request. That's why we're mapping those two things. Then now you might be wondering, यहाँ पे तो capital था S, right? But here we called it like it's a small one. How did it work? The reason is in Go there is no such thing like as a private specifier or public specifier or protected, just like we have in other programming languages like Java and CP, OOPS oriented language, right? We do not have those kind of things here. So the default way it works is if some method is starting with S, that means it is public. You can call it out from outside. But if you define it using a small letter here, you won't be able to call this procedure. So that's the programming construct of Go, and how we define public and private classes is this is the way. So that's why we have called it using small, but as it was a public function, that's why we have defined it using S. But still it is be callable using the small letter like this, camel case like this. So that's about the entire code base. I'm going to push it in my repository. You can check that out from here definitely. Now if you go to the load testing result, if you see, which I ran previously, I'm inside kya? REST microservices folder, right? So this is the REST based output. So the REST based inter microservices communication ka latency was around 90 milliseconds, and number of requests it completed was 46,000. But if I same thing, if I show you here for my Go based request, gRPC based request, I'm inside a gRPC folder which I had run earlier at gRPC. My P95 latency was 9.68 millisecond, and I was able to complete around 49,000 requests, or almost 50,000. So almost 3 to 4,000 more requests than the REST endpoint, REST based microservices communication. So in our second run, what we saw, my REST based output was 84 milliseconds, right? And it again completed somewhere around 46,000 requests only. P95 latency was 84 millisecond. Same for my Go based load testing. I was able to cover around 50,000 requests again 3 to 4,000 more than the REST based communication, and my P95 latency was 8.7 milliseconds. So 90 to 9 and 80 milliseconds to 8. That's a huge improvement in terms of the communication. The number of data set available with them was same. It was 5,000. Everything is same, just that the way of communication and the protocol and the data serialization and deserialization tool was different. Here the protocol was REST and data serialization we used JSON. Here the protocol was gRPC, the data serialization and deserialization we used was Protobuf. So with the power of gRPC and Protobuf, we are able to get a improvement of 90 milliseconds से 9 milliseconds. Then again 80 milliseconds से 8 milliseconds. Almost 10x का improvement we noticed. So that's a huge. So when you are building large scale systems, you have to think about gRPC definitely. Alright, just relying on REST based communication between multiple microservices, and if you have multiple microservices, different kind of microservices which are communicating with each other, वहाँ पे अगर REST if you use, then you might land into latency issues definitely. But if you implement gRPC and think about gRPC with Protobuf, you will definitely see a significant amount of improvement in terms of the latency. You see, we just tested out with how many users? We tested with only 200 users, right? But if we talk about scale, this is nothing. So when you go for a large scale where millions of requests will be coming at per second, thousands or hundreds or lakhs, millions of requests will be coming to your servers per second, these numbers will improve more. All right, and the gap will become huge between the REST based latency and the gRPC based latency. So anyways, as I told, I'm going to push this code. You can check out and do your testing here. One more better approach to actually benchmark this will be, instead of having two different code bases, what you can do, you can have a single client like here. Okay, single node.js based client. So यहाँ पे क्या कर सकते हैं आप, you can define two endpoint. Okay, and similarly you can have a similar Go based service. All right, where you can make it to support both gRPC and REST. Okay, so if request is coming on REST, so you communicate with it via REST. If request is coming from gRPC client, you should communicate with it via gRPC. Okay, and then you can have a load testing script here, right? You can write a load testing script here using K6, and then you can run it, and do a proper benchmarking with a single code base. So that as activity I'll leave up to you. Then let's just do it and share the results with me. I mean, how did it work, and what percentage of improvement you noticed in both the communication protocols. So I have already discussed about the gaps between REST, gRPC, and WebSockets in one of my previous video. I'm attaching that in the I button or the description section. You can check that out also. There I've discussed the pros and cons of each of the protocols and when to use what. So I hope you like this video and you understood and you got to learn something about practically. If you got any valuable learnings from this video, please drop a like. Let's target for 50 likes in this video. I'm targeting to reach 3,600 subscribers by the end of this month. So keep supporting. So if you have any questions, let's just discuss in the comments. Okay. So thank you for watching this video and I'll see you in the next one. Thank you.